Hello, I'm Jonathan and I'm an application engineer. If you're like me, I have a deep interest in people with special skills. And not only that, I like to know how they apply those skill sets. So that's where my friend Justin comes in. You see, Justin's a magician and he has the ability to take a metal fork and twist it right before your eyes. Now what's so interesting about that is even a child knows that we just don't have the strength to put a twist in a fork. And so I thought, let's use SOLIDWORKS to debunk my friend Justin. Will you take a look with me?
What?
In point one, we can use SOLIDWORKS motion to find the force needed to move the fork on the floor.
Pass your hands through mine. Feel any springs, wires, magnets? Pick up the fork. Nothing, right?
Do it again.
Hey, you checked it out, right? I'll do it right up here. Watch.
Look at it! Oh my, it's separating!
You can see that.
In point two, we use SOLIDWORKS simulation to find the force needed to bend the time.
Here, hold your thumb out. Push that back. Does that push back easily? No, that takes a bit of strength. Here, help me. Hold it. Just figure it out like this, right? And just rub it back and forth like that.
In point three, we use SOLIDWORKS simulation to find the force needed to bend the handle.
What?
Okay, here, watch. I'll do it right up here. Watch.
Again, in point four, we'll use simulation to bend the handle even further.
Here, just for you. Let's straighten it out. All right, let's really straight. Watch.
What? No.
No. With your eyes?
No!
Are you twisting it? Oh my God.
In point five, we use SOLIDWORKS simulation to twist the handle a full 180 degrees. This is my favorite.
Take that. Untwist it.
It ain't gonna budge. What? It's not gonna budge.
You can't untwist it, can you? Watch. We'll do it right up here. Watch.
Finally, in point six, we use simulation to bend the final 2 tines out.
Oh my God.
Dude, that was a good fork. I'm telling you, dude.
Keep that.
That was a good fork.
I love that! We're going to use SOLIDWORKS motion to find out how much force it takes to move the fork across the floor. We're also going to use simulation to find out just how much force it takes to bend these tines. If you do a quick search from NASA, you're going to find out that the average force from a male, right-handed male, is about 60 pounds. So that's one of our constraints. And you can see that I've done all the simulation work, so come on back, subscribe to us. I'm going to follow up with 6 videos going through each of the details and the setup and what you need in order to finally debunk the metal bending mystery. We have more blogs and video at simsolutions.com, or you can give us a call or contact support by sending us an email. We'd love to hear from you. Thanks for joining us and have a wonderful day.